Welcome everybody to the channel. In honor of October being not only, when National Fossil Day happens, but also Halloween. When I think of Halloween, I think of skeletons, and when I think of skeletons, I think skulls. So I figured we'd show you guys some of the skulls we look at here, and some of the skulls I use for education here at the Mammoth site, because one of the cool things about looking at skeletons and fossils is that skulls are really useful for telling us a bunch of different things about an animal. So sometimes it can be obvious material, such as our saber cat right here. One of the ways to tell a cat is a saber cat is by its massive sabers. But not only can we use this to figure out what animal we're looking at, we can also use it to figure out, to learn about the animal's lifestyle. These massive canines, from what we can tell, were best used for acquiring prey. They probably wouldn't have been used for chewing like we use our teeth for, but helping them acquire prey, and then they would use the rest of their teeth for that chewing surface. But what's also cool about looking at skulls is not only can we see differences in animals, we can also see similarities. So when we look at our saber cat skull, I'm going to put this guy back over here, we can see, if we compare him to this North American lion skull I have right in front, there are a lot of similarities between the structures of these two skulls. We can see similarities in their teeth. For example, as cats, they both have pretty sharp bladed teeth throughout their mouth, whereas if you look at, for example, our skulls, our human mouths, we have sharp teeth towards the front, flatter teeth towards the back, suggesting a more omnivorous diet, whereas when we look at our big cats, we generally see them as more carnivorous. We can do a similar thing looking at fossil bears, comparing them to modern bears as well. Here at the Mammoth site, the largest carnivore we find at the site is Arctodus simus, our giant short-faced bear. Now if you look at his chompers, you can see again he's got sharp teeth in the front, flat teeth in the back, kind of like us, though his are generally a lot bigger, and also his skull's a lot longer than ours are as humans. When we look also, even comparing this guy to modern bears, such as this polar bear, you can see those distinct similarities in the overall structure of the skull. When we talk about the shape and structure of bones, we often refer to it as the morphology of the bones. But what's really cool is if you look at our saber cat, the saber cat that's a replica that we have here, and our polar bear replica that we have here, and our short-faced bear replica that we have here, even though they're bears versus cats, we can still see similarities in their skulls, and those similarities are even a through line in almost all mammal skulls. For example, if we look at mammal skulls, we see a single hole kind of behind the eye on their skull, and that's part of what denotes mammals as part of the group of animals we call synapsids. Now that's really important. When we look back in the fossil record trying to find some of the earliest mammals, we can kind of look at that skull morphology, and if we see that one hole, we know, okay, we're looking at a synapsid. We know we're looking more likely at something that's more likely to be a mammal than something else. It's also useful if you look at a critter like this guy here, Dimetrodon. With Dimetrodon, he often gets lumped in with the dinosaurs, but because his skull only has that one hole behind his eyes, he's actually more closely related to mammals than he is to the dinosaurs. And we see this through line with all mammals. Our saber cat has it, our polar bear has it, this bat that we've enlarged has it. If we look at this bison skull, this bison priscus, it's still got that hole in the back. Humans, we have that same hole. And even things like prairie dogs have that same hole. In fact, you can actually kind of feel where that hole is on our skull. Like if you take your hands, put them on your temples, and kind of move your jaw around when you feel that little movement, basically that hole allows for extra muscles in our skull and allows us to have a little bit more biting force throughout times. And now, when we look at different skulls as well, we can see some similarities. When we look at bigger skulls, some of them have this big ridge in the back. That's what we call the sagittal crest. That is, allows for extra jaw muscle attachment. So when we look at that, we can see, for example, animals like a saber cat or a bear are going to have a much more powerful bite force than, say, a human, because we don't have that same ridge. We can also see interesting things in kind of seeing how animals are adapted for using their teeth for different ways. Not all animals use their teeth just for eating or just for acquiring prey. If we look at our miniaturized hippo skull that we have 3D printed, you can see it's got these really big, sharp front teeth, kind of like tusks, towards the front of its mouth. And when we see modern hippos using those in the wild, they're often using them as kind of a way to kind of basically it's used for intraspecific fighting. Basically, hippos will fight with each other. They use them for protecting themselves against potential predators. all kinds of things like that. What's also really neat when we look at different skulls, talking about some of the differences in the morphologies, we can see even slight changes in the morphology. So right here, we've got a bison priscus. You can see its skull morphology. And then we've also got bison antiquus, all the way up to probably the most distinct bison, bison latifrons. And so you can see there are some things about these skulls that look almost identical. There are some things, in the case of latifrons, these massive horns, that make them look very, very different. And so one of the cool things that I always like to talk about with looking at skulls is they're kind of a great way of seeing a little bit of everything about an animal. Not only can you see what they're eating, you can see some of the ways they interact with the world by looking at, where their nose would be or where their eyes would be in what the animal wants to live. We can also look at the back parts of skulls and get an idea of the size and shape of the brain of different animals, and see what parts of the brain that different parts of the brain kind of indicate different better senses of smell or better senses of hearing, and so we can kind of try to infer that with prehistoric animals by comparing them to their modern relatives and seeing the differences in their skull morphology. We can also look and see just even minute differences when we look at an animal like a prairie dog, and then also an animal like a rabbit. One of the interesting things that you can see is that they both have those really long front teeth, what we call our incisors. Now, in both of these animals, their incisors, basically they constantly chew on things so that way their incisors don't get too long. But one of the interesting things is that rabbits and pikas are actually part of a group we call lagomorphs. And one of the ways you can tell is because they have a second tiny little incisor tooth behind their front incisor. And so you can see that in the fossil record and see how they're changing. And then of course, we've been talking a lot about mammals, but we can also see differences in other kinds of animals as well. For example, if you look at something like a gaboon viper, their skull generally has much more long, thin bones, because when their jaw and their skull, they're opening their mouth super, super wide to swallow prey whole. And so that helps facilitate that. They've also got these really, really long fangs in the front, and much like a saber cat, they're using for acquiring prey, though instead of with a saber cat, the saber cats, they're biting down and helping them kind of bite and stuff. When gaboon vipers bite, they're injecting venom. And of course, gaboon vipers being a type of snake, their skull morphology is going to be very different than the mammals we see. One of the other cool things I always like to talk about is when talking about these similarities in skulls, we can see those all through time looking at different skulls. So this right here is a replica of a hyenodon skull. This is a type of animal that you might see in Badlands. It's a White River type fossil, and you can see similar morphology in the skull to other animals and other mammals in those same groups. And so it's a great way to see not only some of the various ways that animals interact with their world, but also ways that they're similar. And so if you're wanting to see all of these different skulls that we have, all these different skulls that we look at here at the site that we use for teaching, you can come to our October Fossil Fright Night on October 26th from 6 to 9 p.m. We're going to have our skull station. We're going to have a station where we talk about some of the different types of droppings that we study, and different droppings and how that can inform how we understand different types of animals. We're going to have a slime station. We're going to have some different activities looking at with microscopes, things like that. All kinds of interactive and show and tell type stations for you guys to check out. So with that, we hope to see you at Fossil Fright Night.